Hey everybody, it's time for another math question with Enoch. Determine all positive integers n with at least 4 factors such that n is the sum of the squares of its 4 smallest factors. This question was taken from SMO 2018 Junior Round 2 Question 4. Pause the video if you want to give this question a shot. Now, assume that A, B, C, and D are the smallest factors of n, which is what we want to find. So n is equal A squared plus B squared plus C squared plus D squared. Now, every number has a factor of 1, so A has to be 1. Now, we are going to consider n. If n is an odd number, all its factors would be odd numbered. So, it would be odd square, which is the number odd square plus odd square plus odd square plus odd square. However, odd square is equal odd number, and 4 times of an odd number will become even, which contradicts the statement. So n is definitely an even number, and B is 2. So if odd number is 1 and the even number is 2, we need another odd number to make it even so that n can be even. So we're going to consider letter C, since A and B is 1 and 2 correspondingly. So if C is 4, we are going to consider what will be the value of n, which will be 1 square plus 2 square plus 4 square plus bracket 4x minus 1 square or bracket 4x plus 1 square. Now, as I mentioned, 4 square is an even number, so 4x minus 1 square will have to be an odd number. So, why do I have 4x minus 1 square or 14x plus 1 square? Now, 4 times 3 plus 1 is equal to 13. However, 11 is also 4 times 3 minus 1. So these are all possible values of D if C is 4. So we add them up. 2 square plus 4 square plus 16x square plus minus 8x plus 1 square. Now the first 4 values are divisible by 4. However, 1 and 1 square cannot be divided by 4. Thus, there will be a remainder of 2 if C is 4. So, 4 cannot be a factor of n. C also cannot be a composite number, as if you divide C by the factors of C, you will also be a factor of n, which is also a smaller number. So C must be a prime number, which is odd eventually, and D is an even number, so I do not create new factors of n. D is also equal to 2C because I do not want to create new factors for D. So it is just 2 times C, which will be the fourth factor for n. So n is going to be 1 plus 2 square plus C square plus 4C square. Now 2C bracket square is 4C square. So 5 plus 5C square, if I factorize it, it will be 5 times C square plus 1. So C or D can be 5. However, D cannot be 5 as C is an integer. So if D is 5, C would be 2.5, which does not answer the question that C has to be an integer. So C has to be 5. So we have rewritten the values for 1 square plus 2 square plus 5 square plus D square. Now since D is equal to C, D is 10. So A is 1, B is 2, C is 5, D is 10, and N will be C times C square plus 1. Since C is 5, it's 5 times 5 square plus 1, which is 5 times 26, which is equal 130. That is the answer to the question. Thanks for watching and subscribe to